Well, the next speaker should have been Mathieu Montes, the head of the French Society of Chemoinformatics, but frankly, being head of the French Society of Chemoinformatics doesn't protect you from COVID. This virus really doesn't respect anything. Fortunately, we have his colleague here, Nathalie LAGARDE, who will discuss this high-performance molecular structure and dynamics visualization software. So be ready for some video games. Here we go.
Thank you. So as Lagos mentioned, I'm not Mathieu Montes, so he's very sorry for not being here today. And so he was tested positive yesterday for COVID. So my only contribution to the slide is the add of the picture of Mathieu. Today we present the I will present the high-performance visualization of molecular structure and trajectory software called VTX, or VTX en français, that we are developing in the lab for almost 3 years now. So if you want to stay tuned about the new stuff about VTX, we have a Twitter account, but you can also download the VTX code from the GitHub and also the executive software from the website. So VTX is based on a high-performance graphics engine. So high-performance because we used algorithm coming from video games and animated movies. And this high-performance graphic engine allows us to provide real-time exploration of molecules and offline illustration. So this work is based on our previous work about UDOC, that is a protein-protein interactive software tool. And from UDOC, we have developed computer-human interface and control panel that we are now using with VTX. So VTX is based on intuitive UI UX. And we use trackball and free-fly cameras and 3D picking. I will show you a little bit later. So VTX is able to read and write most molecular file formats thanks to the use of the ChemFiles library. So if you are using VTX and you have a problem with the specific file format, please send us a report and we will fix this as soon as possible. And also, of course, VTX is able to read molecular dynamics trajectories. It's one of the main reasons we developed VTX. So VTX is based on a meshless implicit analytical representation. So I will choose this. So most of the 3D software are developed to represent a wide range of different shapes, and they are based on a mesh representation. And this mesh representation is based on small triangles that are plugged one to the other. And usually you will obtain this kind of rendering because you will see the side of the triangles. Or if you don't want to see this, you have to use a lot of small triangles and the memory load will be very high. And so with VTX, the idea was that we already know the defined shapes that we want to represent. We want spheres for atoms, cylinders for bonds, ribbons, this kind of stuff. So we are using an implicit representation by using the associated mathematical equation to draw the surface. So the surface of the other representation. So the main advantage is that we are able with this approach to have fast rendering and reduce memory usage. And also what we are able to provide a pixel perfect quality, which means that you can zoom again and again and again, and you will still have this pixel perfect quality, this smooth aspect of the representation. So with VTX, you can have several molecular representations that you are used to: Van representation, sticks representation, cartoon, and SES. It's coming soon, so if you are downloading today VTX, you will not get it, but in the next release, that will be very soon, there will be the SES representation. VTX is also based on a system of lighting that is specific, that is called screen space ambient occlusion. so SSAO. So this is an example of the difference when you don't use SSAO and when you use SSAO. So SSAO enables you to get a sense of the depth when you visualize, and it represents the atoms according to the environment. So if an atom is placed in a crowded environment, it will not get a lot of light, so it will be in a shaded, dark place, and this is how we obtain this kind of rendering. So we also provide different shading modes, so flat lighting, diffuse lighting, and glossy lighting. So I will show you later that you can choose the parameters you want to use. And in the other rendering effect, we have an outline rendering effect that we are using now for when you select a part of the molecules. It will be outlined like this to show you what you selected. And we also have a fog rendering effect that enables to put to visualize in more precisely some part, and the other part of the structure is in the fog. So it's a visual effect, and if it's Halloween, you can use the poison fog rendering effect that was developed specially for it. As I told you in introduction, we can read a lot of molecular formats that are enabled by the Chem5 library. So MOL2, PDB, NMSCF, and whatsoever. So, and you can also we have an API that enables to download directly from the PDB the structure in MFTF format. And we also have a MD trajectory navigator that allows you to load your MD simulation trajectories and visualize them. So VTX is provided with predefined presets. And so if you are using VTX, you will be able to very easily visualize your system, but it was also conceived to be the most user-friendly possible. So you can use the settings window to change a lot of parameters, and you can save this parameter to use them again with another system, or you can even share your parameters with your colleagues that are also using VTX. And VTX also use intuitive manipulation and selection tools. So for example, for the sequence, you can select part of the molecules in two different ways within the sequence, within the sequence window that is on the top of the interface, and in the scene window that is on the left on the interface. And we also provide two camera modes. One is trackball. So when you move the camera, you will rotate around a target point that will be fixed. And you also have a free fly mode that enables to navigate around the system. So this is a movie that will show you everything that I've said until now. So you can charge a system that you want, or you can download it. So this is the human deoxyhemoglobin system. And you see that here in the movie, you can have the sequence here or here. And you can select stuff from the sequence, and you can change the representation of the selection. So here you have cartoon mode that we will improve soon. And we have also the ball and stick mode. And you can use the preset settings to change the stuff very easily and fastly. And so this is the free cam mode. And as you can see in this scene, there is around 10 million atoms that are presented. So this is the protein beer and breath party. And so this was captured with a 6 years laptop with a graphics card that is not so performant. So it's a crucial point for VTX. You can use it with any computer, and the performance will be very high. This is a scene that was broadcast on Arte, French and German channel television, to illustrate an interview that was done during the COVID situation about the spike proteins. And so VTX was famous. There is still a lot of work to do. And I will show you some stuff that we are working on right now. So for the molecular dynamics part, we want to implement an interface to prepare the system for the molecular dynamics, and also a trajectory streaming system that allows to visualize the trajectory without taking too much memories. We will also provide tools for illustration and movies. And for the molecular visualization part, I will detail a little bit more in the next slide. But what it's missing right now, and that we are asking a lot about it in the team, is the structural alignment. So now, if you are using VTX, you cannot align two proteins, but soon it will be possible. So the other stuff that the developers are working on right now is the real-time pace tracing. So it allows to have in a real-time way, the ray tracing of the molecules. So it works by sending ray light in all directions, and the quality improves as soon as you stop moving. So this is something that we are working on right now. And you can change a lot of setups when you are doing this also. The other stuff we are working on is the implicit SES representation. So as for all the rendering in VTX, we want to have the perfect SES construction using the implicit equation that were formalized by Mumpon and Stamp in 2016. And so compared to the reference method that are control build-up and other kind of stuff, we will provide a much faster and pixel perfect rendering. And we also want to have a real-time construction and rendering to provide the SUS for MD trajectories. So this is something that is quite hard to implement, and a PhD student is working on it right now, and we hope that it will be available next year. So this is an example of what we will obtain kind of rendering for implicit SUS. And also we have new materials lighting effects. So we have glow effect, that is this kind of stuff that we want to also implement when you will select some stuff with VTX. With the glow effect, it will show you what you select more precisely. And we have also emissive materials, so I think you cannot see it very well. It was something that was asked during the GGMM presentation at VTX. Somebody asked if we could do this effect, so we could. And the last thing, we want to implement the work we've done with UDoc. So UDoc, that is the protein-protein docking interactive tools that we have developed a few years ago. And we want to include it in the VTX. So there will be still the interactive multi-body docking with real-time energy calculation, the intuitive camera control, and also, because it's super cool, the spaceship avatar mode. So to finish, I have to analyze a lot of people that are working on this project. So this project is a part of collaboration between our team and a team that's more based on graphical development. And I want to give a special thanks to Mathieu and Simon that helped me prepare the presentation yesterday.
Excellent, very impressive. I see the qubit story. You don't use quantum computers for those images, right?
No.
No. It's impressive, you know.
Qubit is the partner it's something I did not mention. It's totally free for academics, but we will also have an industrial license, and Qubit took this industrial license.
Interesting. Questions?
Hello, thank you very much. It was very, very impressive. I have a question. Is it just standalone program, or do you have plans to do that on Navigator so that we can maybe interact with the program with?
It's something we've discussed. For now, it's just standalone, but we are thinking about doing it also.
Nice.
Well done. You made it 5 minutes earlier. You can breathe for 5 minutes and then join the tutorial.